So, very good morning to all of you. Am I audible?
Yes, sir.
Yes, sir.
Okay, can you see the screen share?
Yes, sir.
Screen share is visible. I hope it is visible. So, in the last class, we were discussing about the resolution of a force and also the composition of a force. In case of resolution of a force, we are going to divide the force, a given force, into two components along two mutually perpendicular direction. Then we can find these rectangular components, f of x and f of y. And if you can get back the original force, f is equal to square root of f of x square plus f of y square. So we have discussed how to resolve a given force in a given force system. And the concept of resolution of a force will be very helpful in finding any unknown force in a given force system. And the force has been divided into two components along x-axis and along y-axis. There is no hard and fast rule that you have to resolve with respect to horizontal axis. You can also resolve the given force with respect to the vertical axis. So this we have discussed in the last class. And next is the composition of forces. Composition of forces is nothing but you are going to combine two or more forces into a single equivalent force, that is known as the combined effect. The process of combining the forces and finding out the combined effect. So this combined effect is also called as the resultant force, which produces the same effect on the body that produced by the individual forces acting together. So these things we have discussed. Now, the resultant of a given force system can be found by using the law of parallelogram of forces and the law of triangle of forces. Now here, so this is a given body and it is subjected to the forces F1, F2, F1 and F2, F3 and F4. And here F1 is making an angle theta1 with respect to x-axis, and F2 is acting vertically downwards, and F3 is acting also with an inclination of theta2 with respect to vertical axis, and F4 is acting in the horizontal direction. Now, you can calculate the algebraic sum of forces acting along x direction and the algebraic sum of forces acting along y axis. Now, if you take the reference axis here, x and y, so now you can add the forces along x direction and forces along y direction, and you can resolve the given force, which is having an inclination with respect to x-axis and y-axis, by using the concept of resolution of a force. Now you can see here the sum of horizontal forces, that is, you can call it as sigma f of x. Now if I take the reference axis like this, that is y-axis like this and x-axis like this, you can see here F4 is acting along x direction, the positive direction. So it is plus F4 plus F1 cos theta 1. Now if I resolve this force, along horizontal and vertical direction, its horizontal component is F1 cos theta 1 acting towards the right direction. So if I consider this triangle, so this becomes the opposite side and this becomes the adjacent side, and this is the angle given. So here, so sigma f of x, so f of x is nothing but F1 cos theta 1. So this is the horizontal component acting towards the right direction. So hence you can see here it is F1 cos theta 1. And if you come to this force F3, so since F2 is acting vertically downwards in downward direction, so we are considering only the components along x direction, that is F4 plus F1 cos theta 1. Next, this is making an angle theta 2 with respect to the vertical axis, or you can also resolve with respect to either vertical axis or horizontal axis. So if I consider this angle, so obviously with respect to x-axis, this becomes 90 minus theta 2. So either it can be, it is acting towards negative direction. So now if I resolve this, if I consider this triangle, so this is the triangle. So this angle being, so let us call it as 90 minus theta 2. So its x component is towards negative direction and the y component is towards the downward direction. So if you resolve this force into horizontal and vertical component, so its horizontal component is minus F3 cos 90 minus theta 2, or it can be minus F3 sin theta 2. Now you can see here, either it can be minus F3 sin theta 2, or it can also be minus F3 cos 90 minus theta 2, 90 minus theta 2. So you can resolve either with respect to x-axis or y-axis. So similarly, now let us find the summation of all the components along y direction. Now you can see here, you have a force F2, correct? F2 acting in the downward direction, hence it carries a negative sign. So it is minus F2 since it is acting towards the downward direction, negative direction. And so if I resolve this force, its horizontal component is F1 cos theta 1 and its vertical component is acting in the downward direction. That is, hence it is minus F1 sin theta 1. You can see here, minus F1 sin theta 1. And similarly, if you resolve this force, vertical component, its vertical component is either minus F3 cos theta 2 minus F3 cos theta 2 minus F3 cos theta 2, or it can also be minus F3 sin 90 minus theta 2, 90 minus theta 2. So if I consider this angle, so this will be its vertical component acting in the downward direction, hence it is minus F3 sin 90 minus theta 2, or it can be, if you consider if you resolve with respect to vertical axis, then it will be minus F3 cos theta 2. So you can take the algebraic sum of the components of the forces along x-axis, and also you can find the algebraic sum of forces of components along y-axis. So this is, here we have used the resolution of force concept in order to find the sigma f of x and sigma f of y. Now let us look at this. This is a very important concept. Now you have 4 quadrants. So this is first quadrant, this is second quadrant, and this is third quadrant, and this is fourth quadrant. So suppose if I have a force here, right, in the first quadrant, its horizontal component will be positive. If you resolve this force, if I have a force here, F1, so if you resolve it, its horizontal component is positive and its vertical component is also positive. So if the force lies in the first quadrant, both the components, that is horizontal and as well as vertical components, are positive. Suppose if you have a force in the second quadrant, suppose if I have a force in the second quadrant, so like this, then its x component is positive, negative. If you resolve this force in the second quadrant, its x component is negative and its y component will be positive. And if you move on to the third quadrant, suppose if I have a force like here, force like this, then its x component is also negative and its y component is also negative. And if you have a force in the fourth quadrant, so its x component is positive and its y component is negative. So this concept will be very helpful whether the force is acting in the first quadrant. If it is in the first quadrant, both the horizontal and vertical components are positive, and if it is in the second quadrant, the horizontal component is negative and the vertical component is positive. And similarly, if it is in the third quadrant, both horizontal as well as the vertical components are negative. And if you have the force in the fourth quadrant, its x component is positive and y component is negative. So when we discuss numerical problem, we will understand this concept better. That means in first quadrant, both are positive. In second quadrant, f of y is positive and f of x is negative. And in third quadrant, both f of x and f of y are negative. And in the fourth quadrant, f of x is positive and f of y is negative. Now, you can find the magnitude of the resultant. So since the resultant is a vector quantity which has both magnitude and direction, so you can find out the magnitude of the resultant by using this equation. R is equal to square root of sigma f of x square plus sigma f of y square. So in this case, we have calculated what is the value of sigma f of x and sigma f of y. So thereby, you can find out the combined effect of the resultant by using this expression. R is equal to square root of sigma f of x square plus sigma f of y square, and this will give the magnitude of the resultant. But we also need the direction of the resultant. So the direction of the resultant is nothing but tan inverse theta is, that is tan theta. Tan theta is nothing but sigma f of y by sigma f of x. Tan theta is nothing but sigma f of y by sigma f of x. And if you want to calculate the direction theta, it is nothing but tan inverse sigma f of y by sigma f of x. So next is we shall discuss how to find the magnitude and direction of a resultant by using the law of parallelogram of forces. Now here, the method of finding the resultant. The resultant of a system of coplanar concurrent forces can be determined by the following methods. So in your syllabus, you only have this, it is law of parallelogram of forces. Now now let us make the statement of law of parallelogram of forces. Now, the law of parallelogram of forces goes like this. If two concurrent forces acting simultaneously on a particle, correct? On a particle, and that means if you have two concurrent forces acting at a point, and these two concurrent forces are represented in magnitude and direction by the two adjacent sides of a parallelogram. So these two forces are represented in magnitude and direction by the two adjacent sides of a parallelogram, and the diagonal which passes through the point of concurrence gives its resultant. So that is the statement of law of parallelogram of forces. So the law of parallelogram of forces states that two concurrent forces, so let us call it as one is P and Q, are acting at a point. So these are concurrent forces which makes an angle theta between these two forces, and these two forces are represented in magnitude and direction by the two adjacent sides of a parallelogram, and the resultant of these two forces is called as the combined effect or the resultant. So the diagonal which passes through the point of concurrence represents its resultant. Now what we have done is we have considered two forces Q and P acting at a point. So the angle between these two forces is theta. So the diagonal which passes through the point of concurrent represents its resultant, and let alpha be the angle of the resultant with respect to force P or the horizontal direction. Now you complete the parallelogram. So first we have considered two concurrent forces acting at a point, and let theta be the angle between them, and the diagonal which passes through the point of concurrence represents its resultant, and let alpha be the angle of the resultant with respect to the horizontal direction. Now you complete the parallelogram, say ADCB or ABCD. So complete the parallelogram. Now you drop a vertical from point C and extend the horizontal line AB, so which intersect at point E. So this construction has to be made. So drop a vertical and extend the horizontal line. So the intersection of these two lines, you call this point as E. Now from the figure, the side AD is equal to the side BC, correct? The side AD is equal to the side BC. So hence this angle is also theta. Now let P and Q be the two forces represented by the sides AB and AD of the parallelogram. The resultant can then be represented by AC, and as shown in figure. To find the magnitude R of the resultant, consider the triangle CAE, correct? Consider the triangle CAE. So you consider the triangle, this triangle CAE. So here AC square is equal to AE square plus CE square. So consider the triangle ACE. So where AC square is equal to AE square plus CE square. So now here AE is nothing but AB plus B. See here AE is nothing but AB plus B whole square plus CE square. Now you consider the triangle CBE. So this angle is being theta. Now the side B is nothing but it is q sine theta, correct? So since side AD and side BC are equal, so this side is obviously q. So if you want to find the sides CE and B, we want to find the sides C and B. So the side C, that is opposites by the hypotenuse. Opposite side is C by the hypotenuse, that is Q. So hence the side C is nothing but Q sine theta. Q sine theta. Similarly, the side B is nothing but your Q cos theta. Q cos theta. Now, so you substitute these values in this equation. That is AC square is equal to AB square plus 2AB, correct, into BE plus BE square plus C square. And here AC square is nothing but R square, AB square is nothing but P square plus 2PQ cos theta into Q square cos square theta plus Q square sin square theta. So if you take cos square theta plus sin square theta will be equal to 1. So hence the final equation will be R square is equal to P square plus Q square plus 2PQ cos theta, and R is nothing but square root of P square plus Q square plus 2PQ cos theta. So this is the equation to find the magnitude of the resultant by using the law of parallelogram of forces. So the law of parallelogram of forces can be applied mainly only when you have two concurrent forces acting at a point. If you have more than two concurrent forces, so you have to go in for the resolution of a force. So if you have two concurrent forces acting at a point which makes an angle, so these two forces can be represented in magnitude and direction by the two adjacent sides of the parallelogram. So thereby you can calculate the magnitude of the resultant. So the equation for the magnitude of the resultant by using law of parallelogram of forces is square root of R is equal to square root of PQ square plus Q square plus 2PQ cos theta. And so you need to find the direction of the resultant also. The direction of the resultant also. Now consider the triangle CAE. So here tan theta is nothing but C by AE, correct? Tan, if you consider the triangle ACE, tan theta is nothing but C by AE. You can see here C by AE. So again AE is nothing but AB plus B. So you know what is AB, B, C. So you substitute here. So you can calculate the direction of the resultant, that is alpha, tan alpha. So alpha is tan inverse Q sine theta divided by P plus Q cos theta. So this is the procedure to find the magnitude and direction of the resultant of a given concurrent force system by using the law of parallelogram of forces. So any doubts with this concept? Any doubts? Anyone having any doubts? Is it clear?
Sir. No, sir.
My presentation is okay? Okay. I think no issues with this, correct? So in every question paper, you have this question. State and prove law of parallelogram of forces. First, you have to make this statement. Then you have to construct this figure. So then you have to find the magnitude and direction of the resultant. So this law of triangle of forces is similar to that of the parallelogram law. You have one more law called as polygon law. So these are not included in your syllabus. Only you have the law of parallelogram of forces. Now we know the definition of a force and what are the characteristics of a force and how to identify a force in a given force system by its magnitude, by its direction, by its line of action, by its point of application, and by its sense. And we know the unit of force, and force is always represented by an arrow which has a tip and tail, and the unit of force is Newton and its multiple. And we have also discussed the different classification of system of forces, that is the collinear force system, the coplanar concurrent force system, the coplanar non-concurrent force system. Now, the next concept is now the moment of a force. So next definition is the moment of a force. So how do you define the moment of a force? So the moment of a force has the turning effect. It produces a turning effect on the body on which it acts. Now you can see the definition. The turning effect produced by a force on a body is known as the moment of a force. So when a force is applied on a body. So it has the turning effect. It has the turning effect, and this turning effect is called as the moment of a force. Now, the magnitude of the moment is given by the product of magnitude of the force and the perpendicular distance between the line of action of the force and the point or the axis of rotation, correct? So now you have to calculate the magnitude and direction of the moment. So moment is basically created by a force. So when a force is acted on a body, it produces a turning effect, which is called as moment. So moment is also a vector quantity. So you need to calculate both the magnitude as well as the direction of the moment, whether the moment is producing a clockwise movement or it is producing an anti-clockwise movement. So that can be better understood by looking at this figure. Now you have a body. You have a body. Now you have a force acting on the body with certain magnitude, say F, and we need to find the turning effect of the force on this body about this point. So this point becomes the point of rotation. Now, the magnitude of moment of this force with respect to this point is the magnitude of the force, and the perpendicular distance between the line of action of the force and about the point about which you consider the moment. So you can consider the moment somewhere here also. You can also consider the moment at this point. And this point becomes the axis of rotation. Then the moment of the force, the magnitude of the moment of the force is nothing but the magnitude of the force multiplied by the perpendicular distance or the point about which you are going to find the moment. So this perpendicular distance is called as the moment arm, or it's also called as lever arm, L-E-V-E-R. So it can also be called as moment arm. So this perpendicular distance, that is T, it can be also called as moment arm or lever arm. So hence the magnitude of moment is nothing but the magnitude of the force multiplied by the perpendicular distance. So the SI units of this moment will be generally in Newton meter, because the magnitude of the force will be in Newton, and the perpendicular distance, whether it can be in millimeter or it can be in meter. So hence, when you multiply the magnitude of the force with the perpendicular distance, the unit of moment becomes either Newton meter or kilonewton meter, and its multiple. So basically, moment of a force has the tendency to rotate the body and which it acts, and the magnitude of the moment can be calculated by multiplying the magnitude of the force with the perpendicular distance about which the moment is considered or moment is taken. So now we know how to calculate the magnitude of the moment. That is nothing but the magnitude of the force and the perpendicular distance. Now we want to find the direction of the moment. We want to find the direction of the moment, whether the moment is creating, the force is creating a clockwise movement or the force is creating an anti-clockwise movement. So now here, you can see here, this is the figure body, which is subjected to a force F, and this being the perpendicular distance. Now, if you multiply the magnitude of the force with the perpendicular distance, so this is giving a clockwise rotation, correct? So the force is in the upward direction, and it is creating a clockwise movement. So you can see here, the direction of this arrow, it is showing clockwise movement. So you can see here, clockwise movement. So this force is creating a clockwise movement on the body on which it acts. So the other figure you can see here, the force is creating an anti-clockwise movement. So in order to find the direction of the movement of a force, it is better to keep the thumb of your finger about the point about which you require the movement. You can keep the thumb of your hand about the point about which you require movement, and move the point finger in the direction of the application of the force. So there you will get a turning effect, clockwise turning effect. So hence this force produces a clockwise movement. So here, if you keep the thumb and move the point finger, it creates an anti-clockwise movement. So moment is a vector quantity which has both magnitude as well as direction. So the magnitude of a movement can be calculated by, it is nothing but the product of the magnitude of the force and the perpendicular distance about which you are going to consider the moment, and the direction of the movement, either it can be positive movement or it can be a negative movement. So any doubts with this, ladies and gentlemen? Hello, is it clear? Anyone? You can ask freely if you have any doubts. Am I audible?
Yes, sir.
Okay, fine. So anyway, today, and here next is a moment of a force, and how to calculate the magnitude and direction of the moment of a force. Now, next concept is the couple of a force. What do you mean by a couple? What do you mean by a couple? So couple is nothing but defined as couple is produced when two equal, opposite, parallel, non-collinear forces give rise to a couple. So let us discuss what is a couple of a force. Now you can see here, couple. Two equal, opposite, and parallel forces constitute a couple, as shown in figure. Now here you have two forces, F1, this is also F, and this is also F. Two equal, and they are opposite in direction. Two equal, opposite, parallel, correct? This which constitute a couple. So here two equal, opposite, and parallel forces constitute a couple. Now here you have two forces, F and F, and the distance between these two forces is d, say d meters, and this distance is also called as moment arm, or it is also called as lever arm. So this will constitute a couple. This will constitute a couple. So either you can reverse the direction of these forces. So you can reverse the direction of these forces like this here in the downward direction, and this you can reverse it in the upward direction. So it gives the positive or negative couple. Now in our case, so if you take the moment of this force, it is producing a clockwise moment, and this force is also producing a clockwise moment. If I reverse this figure, so if I force is acting in the downward direction, and here it is acting in the upward direction, both being parallel, opposite, and it is kept at a distance d. So here, if I reverse the direction of the force, it produces an anti-clockwise moment. So hence, couple, you can define it as two equal, opposite, and parallel forces constitute a couple. Now, what are the properties of couple? Properties of couples are, it is also called as the characteristics of couple. Two equal and opposite parallel forces are required to form a couple. The magnitude of the moment of the couple is equal to product of magnitude of one of the forces and the moment r. So that is the perpendicular distance between the two forces. You know how to take the moment of a force about a given point. So the same concept will be used. The magnitude of moment of the couple is equal to the product of magnitude of one of the forces and the moment r, perpendicular distance between the forces. And next is the resultant of forces of the couple is always zero. So because the magnitude of the couple about any point in the same plane, it does not change, it remains same. So hence the resultant of the forces of the couple will be always zero. Now you have the types of couple, whether it can be an anti-clockwise or it may be a clockwise couple. So next class we shall discuss with a very important concept, that is called as Perignon's theorem of moments. So in the next class, hopefully on Tuesday you have my class, so we shall meet on Tuesday. So you have any clarification or any doubts? Now you can mark your attendance in the chat box. Please mark your attendance in the chat box. I'll be ending the session because time is up. Okay, I will be ending the session, and thank you so much. Have a nice day. Stay safe. So I think all of you have marked your attendance in the chat. Okay, you can leave the meeting. Thank you so much.